Hey grade 11s, I am going to record a few videos just to explain the TRIG test that you wrote on the 6th of May. I know you may have seen the memo already and marked your work, but hopefully my explanations will also help you a little bit as well. Right, so it started off with this question that asked you to simplify the expression to a single trigonometric ratio. In other words, they just want a sine of this or a cos of that, and that's all. Okay, so it all hinges around the cost diagram. Okay, or you can say all Selbornians, blah, 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 make your own little rhyme. Okay, and this involves the reduction formula as well as co-ratios. Okay, so that means for reduction formula, just as a bit of a recap, 360 plus theta or 360 minus theta or just minus theta, 180 minus theta, 180 plus theta. Okay, and then for co-ratios, you also can use this area, 90 minus theta, 90 plus theta. Okay, you'll notice that nothing involves the 270-degree axis, so you ignore that one entirely. Okay, so reduction and co-ratio is very important here. Also, I think we're going to find it in this question. You could also remember that tan A or tan theta or whatever is equal to sine A over cos A. That is the quotient identity, which I think we're going to use here as well. Okay, so getting into the question 1.1. Firstly, you'll notice that it says sine of A minus 360. Okay, we do not like that. We want 360 minus A or perhaps 360 plus A, not A minus 360. So the way we go about these, and you'll get used to these after a while, is to take out a common factor of a negative 1. By so doing, you will now have 360 minus A inside your bracket, which looks a bit better. Okay, then sine 180 plus A is going into the third quadrant, quadrant 3, okay, which is tan's quadrant over there. Let's just put 1 and 4. So that reduces to negative sine A. Remember, we are multiplying these two terms at the top. That's not something subtract something. It's timesing. At the denominator, you've got cos of 90 minus A. We are going into the first quadrant. Co-ratios makes that sine A. And the last part here, tan of negative A, you are going into the fourth quadrant. That is cos's quadrant, not tan's. So that becomes negative tan A. It reduces like that. Okay, just before we can continue, you can cancel that sign with that sign. And that negative can cancel with that negative. Okay, moving on. Sine of negative something, right? View this as the angle we're dealing with. So sine of negative an angle is going into the fourth quadrant, which is cos's quadrant, not sine's quadrant. So that becomes negative sine of the angle. And what is the angle? 360 minus A. At my denominator, I can rewrite tan as sine A over cos A. Okay, we'll see why that's going to help us just now. Then, moving on, negative sine of 360 minus A. 360 minus A is taking us into the fourth quadrant, which is negative for sine. So that makes it negative of negative sine A, which makes it positive sine A. Now, instead of dividing by this, I'm going to times by the reciprocal, the upside down, the flip. So it's going to become cos A over sine A. Technically, this sine A is sine A over 1, which allows us to now cancel the sine A's, and we are simply left with cos A, which is now answering our question. We've left it as a single trigonometric ratio. Okay, so there's 1.1. Hopefully you understand and you can see what that's all about. Right, moving on to 1.2. They give us a picture in the Cartesian plane, right, which I'll quickly scribble on this page over here. For 1.2, they give you're in the fourth quadrant over here, right? The angle that's taking you to our story is angle beta. You've got a point over here, that's point H, right? And there's an x-axis, there's a y-axis, like so. The point that we are at is point P, which is the point 3 and T. And we are told that the R value is root 34. Remember, the R value will always be positive and never negative. Okay, it does tell you that in the diagram P, which is 3 and T, is a point in the Cartesian plane. OP is root 34 and HOP is beta. It is a reflex angle, it tells you. Without using a calculator, firstly determine the value of 1.2.1 T. Okay, so in 1.2.1, in order to work out T, we are going to use Pythagoras. Remember, there is a 90-degree triangle here in our story where r squared would equal x squared plus y squared, right? And that's old school Pythagoras, eh? So the r squared's value here would be root 34 all squared equals x squared is now 3 squared plus, and y squared is our t squared's value. Okay, so now to get t squared as the subject of the formula, root 34 all squared is simply 34. I would then subtract 9 on the left-hand side, and that means t squared is equal to that. So t squared is therefore equal to 34 minus 9, which is, what, 25? Is that right? 25. So that simply makes t squared, sorry, not t squared, t equal to root of 25. But now it's important to note that t is not 5, t is negative 5. Why is t negative 5? Because we are in negative territory for y. So t is negative 5. Right. 1.2.2, we have got the question that says, work out the value of cos beta. Right, so now cos beta is asking us for the trig ratio which describes what cos beta is. It's something over something. Cos is x over r. So the x value in this story is 3. And r is root 34. Right, that's all you need to do. You do not need to push buttons and work out beta. They want what cos beta is equal to. In 1.2.3, you are given cos squared of 90 plus beta. Right, you remember I said just now that 90 plus is a co-ratio. So cos squared of 90 plus b, you could see it as cos of 90 plus b all squared. Right? So firstly, dealing with what's inside the big bracket, cos of 90 plus beta, co-ratios will tell us that that is negative sine beta. Now, if we square it, the negative squared disappears, we're going to get positive, and that's going to leave us with sine squared beta. Right? Final answer, done. 1.3, it says to us, given that sine A equals t, right? Express tan A in terms of t. They give you the hint here, and they say use the triangle. Okay, I'm just move my page up a little bit here. They say use the triangle, and they draw it for you on your question paper that looks like this. You've got a 90-degree triangle there. If you've got A over there, sine A, remember, is opposite over hypotenuse. So t over 1. Therefore, this side here, the adjacent, would be 1 squared technically, but that doesn't change a thing, minus t squared. Great. So now using this triangle, they want what tan A is equal to. Tan A is y over x, or in a format like this, opposite over adjacent. So from this corner, opposite is t over adjacent is 1 minus t squared. And we've managed to express tan A in terms of t. I'm going to make a separate video for question 2. Hope that helps.